So why is it a model is 1.5 gigs, but when I go to train it in a GPU, it takes 15 gigs? What's happening is during training, we need to maintain a lot of different information. We need to keep track of activations, gradients, the optimizer. All of these take up our GPU memory. So let's dive into how we can reduce this down. Let's walk through this using a BERT model that's about 1.3 gigs in terms of its weight. Now, when I go to initialize the GPU, that right there takes 1 gig of GPU memory. Then I add the model weights, and you can see we're over 2.5. And then if I go and turn on the default settings for the trainer and transformers, I rock it up to 15 gigs. We're going to start with gradient accumulation. What that's going to do, instead of calculating the gradient in one big chunk, we're going to break that down into smaller steps. This means less GPU memory, but does take a little bit longer to do. Next, we're going to use gradient checkpoints, and this helps us save the activations at points in the computational graph so we don't have to recalculate all of the gradients. Next, we're going to use mixed precision training, and this helps us use both 16-bit and 32-bit together. Now, this doesn't save us any GPU memory, actually costs us a little bit because we need to have versions of both models, but it's going to make everything a lot faster. The last thing I'm going to do is move away from Atom, which takes a lot of GPU memory, go over to Ada Factor. This is a taste of all the tips and techniques people use to conserve GPU memory, which often is the stumbling block for when you're training these models.